This video is about how to graph exponential functions. So an exponential function is something that looks like this, where I have y equals a times b to the x. Okay, so y is our dependent variable, x is our independent variable, and a and b are both constants, with b being greater than 0. B is greater than 0, so you don't get into any weird stuff going on. So let's look at an example. Let's say that I want to graph f of x equals 2 to the x. Pretty straightforward exponential function. And I want to do it between -4 and 4. The first thing you should do when graphing exponential functions is make a table. So I'm going to have a table of x's and a table of my f of x's, my functions. I'm going to use y too. It doesn't really matter. And try to draw straight lines. Do poorly at it. Okay, so I have -4, -3, -2, -1, 0, 1, 2, 3, 4. Just barely fit it. Okay, so then what I'm going to do is I'm going to plug the exponent into the x and see what I get. So 2 to the -4th power. Remember that when you have a negative exponent, like a negative power, that really just means is you're doing 1 over 2 to that positive power. So 2 to the -4th is really just 1 over 2 to the 4th. Okay, so I know that 2 to the 4th is 16, so that means I'm going to get 1 over 16. 2 to the -3 will be 1 over 8, then 1 over 4, 1 over 2, 1, and then 2, 4, 8, 16, where I'm just doing my powers of 2. Okay, and then you want to graph it. So I'm going to graph it, and since we're going between -4 and 4, I want to make sure I have room in both my second and first quadrants. So we'll do 1, 2, 3, 4. 1, 2, 3, 4. And then we're going to go all the way up to 16. So here we go. 1, 2, 3, 4, 5. I space this badly. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Maybe they got a little closer together, but that's okay. So then I'm just going to go through. So -4, 1/16. That is, 1/16 the distance between 0 and 1. It is so close to 0. I'm just going to draw it right here. Then I have -3 1/8. So that's also, that's going to be just like barely higher up. And then 1/4, same thing, barely higher up. 1/2, I'm halfway there. And then 0 should be 1. And then 1, we can start actually going up. So 1 is 2. 2 is 4. 3 is 8. So 4, 5, 6, 7, 8 around here. And 4 is 16 up here. So my spacing is pretty bad because this looks a bit linear over here. It really should look more curved like this. I'm just going to draw this like what it should look like. So it'll be like this, and then it'll curve up like that. That's what it should really look like if I had drawn my spacing correctly and actually gotten the nice exponential curve. So because as you go left to right, it's increasing like this, this is what's called exponential growth. Okay, where if I look at the difference, right, if I do 16 divided by 8, that's 2. 8 divided by 4, 2. 4 divided by 2, 2. This continues, right? 1/4 divided by 1/8, 2. The whole time what's happening is, or if I'm going in the other direction, is we're doubling it. So I go a little bit to the right, doubles, 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 and it keeps on doubling. So I'm growing as my x values become larger. That's why it's called exponential growth. Okay, so let's look at another case where we'd have, instead of exponential growth, we have exponential decay. So let's get something like f of x equals 1/2 to the x instead of 2 to the x. Okay, so here you notice I chose a number between 0 and 1. When your b value is between 0 and 1, you're going to have exponential decay, and when it's greater than 1, you're going to have exponential growth. So it's a nice, quick, easy way to check this. So I'm going to do my table again. So I'll say -4, 3, -1, 0, 1, 2, 3, 4. And this time, you're going to get the same thing as you did before, but it's going to be flipped. So if I have the 1/2 to the -4th, that's just the same as flipping, right? Taking the reciprocal of this and raising it to the 4th. So it's going to give me 16, 8, 4, 2, 1. And then I'm going to go the other way. So I'm going to get 1/2, 1/4, 1/8, 1/16. Draw my axes. And then this time, if we graph all of these individual points, where we have -4 and 16, let's say, is way up here. And then we should have half. We go down half, we go down half, down half, half, half. Okay, I did a better job of drawing it this time just by trying to cut it in half each time. So now you're going to get what's called exponential decay, where you have something that curves down. Wow, that's bad. And gets really, really, really close to 0 without ever touching it, right? And it goes, yeah. So as the values fall like that, you're getting exponential decay. So now let's look at one more case where I have a number multiplying my values. So I don't just have 1 times whatever my exponent is. So let's look at something like y equals 3 times 2 to the x. Now let's just do this one from -3 to 3, because the numbers get a bit large. So here I'm going to have -3, -2, -1, 0, 1, 2, 3. So I'm going to do 2 to the -3 is 1/8. I'm going to multiply that by 3 afterward. So I'm going to get 3/8. And then -2, I'm going to get 3/4. And then I'm going to get 3/2 and 3. And then 6, 12, 24. Right? Where this is 3 times 2, 3 times 4, 3 times 8. Okay? So then you're going to still get the same kind of exponential growth, because this number is bigger than 1. But it's going to be even slightly faster and larger than the original was in terms of if we just had 2 to the x. So if I graph this, now you can see, right, the highest we went before was 16. But this time, and that was with that x equals 4, we had 16 when we just had 2 to the x. So if I have y's, let's do 2 different colors. Let's do blue. So let's say this will be, I'll graph first, y equals 2 to the x, right? So 1, 2, 3. Okay. So I know that 3 is supposed to be 16. So let's say this is 3 is 8. Let's say this is 8, and then we have half as high as 4, and then 2, and then 1, and then like 1, 2, 3. And then we're going to have down here. Okay. So this is the curve of y equals 2 to the x, which grows like this. But if I switch back to 3 times 2 to the x, then I'm going to get something that grows faster, because now I have 0 is 3, right, instead of being 1. So 3 is probably around here, and then 2 is 12. So already we're like way up here, right, because this was 8. And then, even if we go -1 is 3/2, which is 1.5, so that's here. And then we have 3/4, which is here, and 3/8, which is about a half here. So now we have this. Okay, so you can see that they're both exponential growth, but if I have a number like this out front of it, then it's going to grow faster than my standard y equals 2 to the x. If instead I had, let's say, 1/2 out front, then it would grow slower, right? I would get an exponential curve that, maybe would look like this instead, right? Where this would be y equals 1/2 2 to the x. Okay. So all of these are exponential growths. The number out front just controls how fast the function grows. But the general approach here is you want to make a table. You want to make sure that you're plugging in your values and that you're doing it carefully. And you're remembering what negative powers mean. It means you're doing 1 over 2 to that power. It doesn't mean you're making the number negative or anything like that. And that's how you graph exponential functions.